Hi, and welcome to the Power of Clean C++. My name is Ann Campbell. I'll be your moderator today. I'm going to get started with a little bit of housekeeping. So if I can have that slide, there we go. So this will be a 30-minute session, including Q&A. Please use the Q&A box to ask your questions, not the chat box, but the Q&A box. We do have two panelists standing by to answer your questions. They are Yassine Maghezi and Ebes Sabra from the C Family team. So they are the experts on this topic, along with our speaker, Phil Nash. They are here to answer your questions live in the Q&A interface. We also will be forwarding some of the questions you asked to Phil to answer live. The questions that don't get asked, we will follow up. So within a few days, we'll post all of the questions and answers. And you will get that link to those questions in the email along with the recording. We will give you a survey after the webinar is done. Please do answer the survey. Tell us what we did well, tell us what we did wrong, what we need to work on, what you would like to see in future sessions. And now I'd like to introduce our speaker, Phil Nash. He is the original author of the C++ test framework Catch 2. He's the host of several podcasts. He's a member of the ISO C++ Standards Committee. He's a trainer specializing in TDD. He's the organizer of C++ London and C++ on C. And in his quest to improve the state of C++ software quality, he has become a developer advocate here at Sonar. And without further ado, I'm going to turn it over to Phil. Thank you, Phil.
And thank you, Anne. And thank you, everyone. All 283 of you so far who've turned up to watch this. The number's actually still ticking up. Welcome to the power of clean C++. So we're going to be talking about clean code today in the context of C++. And I'm going to get to what that actually is in a moment, but I actually want to start with the why. Why should we actually care about clean code? And to get us kicked off, I actually want to ask you all a question. So I'm going to open a poll in a moment. And it's going to be, what is your biggest pain point as a developer from these four choices? So if you've got other ideas, I'm afraid we have to stick to these four. So testing, fixing bugs and errors, requirements gathering, or estimating a level of effort. So I think all of those are considered pain points. So I've just launched the poll. Hopefully you should see that there now. And I see some votes coming in. So that does seem to be working. Give it a moment to take everyone's votes. $303 people watching now. So for those that have just joined, we are running a poll. Still very active. I'm going to compare this in a moment to a report that came out a little while ago, and some conclusions drawn from that report as well. But I want to get a sense of what this audience is like here. Starting to settle a bit. So yeah, it's actually pretty close to what the report says. So fixing bugs and errors in the first place, followed by estimation and then testing. So the report that I had in mind has these figures. So fixing bugs and errors is the number one, just about, pain point, as surveyed by 1,000 developers in the top four pain points, closely followed by testing. That was a little bit further behind in our poll. Then requirements gathering and estimation. So yeah, that number one, fixing bugs and errors, has definitely been a consistent pain point for any developer. And in fact, there are more figures in this report that I wanted to pull out. By the way, the URL is at the bottom of the page there, but we are going to provide the list of references that I'm going to talk about a little bit later anyway. So if you don't catch it here, don't worry too much. Still got time to read that on your own. So, dear developers are spending too much time fixing bugs. Apparently 8% of developers spend at least 75% of their time fixing bugs. That's obviously far too much. But 37% said that they spend more than 25% of their time fixing bugs. Nobody likes fixing bugs. So the report actually goes on and even polls, what developers would rather be doing instead of fixing bugs and finding errors. 26% would rather be spending their time paying bills. 21% would rather go to the dentist. And 20% would rather spend time with their in-laws. I'm not sure if there was a follow-up question of whether they actually like their in-laws, but you get the idea. Slightly more seriously, though, yeah, we're spending too much time fixing bugs, but arguably that's not actually enough because there are still so many bugs that haven't been fixed. And really this leads on to the bigger problem. Because, yeah, we might think about how we enjoy our time, but a lot of the time it comes down to money. What's it actually costing us to have all of these bugs as a result of poor quality software out there? So there is another study from the CISQ this time, the Consortium of Information and Software Quality. They do a report semi-regularly on the state of software quality, just in the US. And they just recently, I think it's just last month actually, brought out their 2022 report. So if you've seen previous figures in this area, these are the latest ones, right up to date. And they put a figure, a price, of what it's costed the industry, just in the US, as a result of poor software quality, bugs and errors that are not fixed, not the ones that we actually caught, but the ones that made it through. And this report says that in this 2022 update, the cost of poor software quality in the US has grown to at least $2.41 trillion. If you've read previous reports, they often talk about billions, but it's actually got into the trillions now. $2.4 trillion just on software quality issues. There is clearly a very real need here for us to do something about it. Now, I'm sure most of you are developers. As developers, when we see a problem that is tedious, where we try to automate fixing it, and you can't do that for every aspect of software quality, but there's a lot that you can do. There are various tools and techniques to reduce the scope of bugs, to increase our software quality, and just make our quality of life better. In my career, I've talked about many of these. Today, I'm going to be talking primarily about static analysis and some other tools around that we provide here at Sonar to help developers to increase their software quality and get some of their life back, because really that's a part of it as well. So that's what we're here for, to see some of this. So I'm going to start by giving a demo of SonarLint, which is our linter. It's a plugin for various IDEs. Chances are the IDE that you use already works with it. And I'm going to be using C-Line today. I'm particularly familiar with, so I'm just going to change my screen share. Bear with me 1 second. Here it is, I think. Okay, hopefully you can see my C-Line there. Now, I've got a few things I want to show you. A couple of them are taken from a coding quiz that we did at the ACCU conference earlier this year. I thought they showcased this quite nicely. So this is one of the questions that we had. Some somewhat complex code. It's actually code that you'll probably see something like this quite a lot. And yeah, we've got some templates there. Got std enable if _t in there. We've got some forwarding going on. Down here, we've got a shared pointer and a wrapper. And the idea is we've got to work out whether this compiles, and if it does, whether it prints false or true. That was the quiz question. Now, what I've done here is I've actually suspended SonarLint from running. Normally it would automatically run, as we'll see in a moment, and tell us immediately where problems are in our code, at least the ones it knows about. I've suspended it so that we can have a look at that without it first. But I'm going to open the SonarLint panel and resume the analysis. And now you can see, well, it's found 3 issues actually. Let's have a look at them. Well, the first one, that's std enable if _t. It's telling us that we should replace this with a language construct. Abbreviated function template, requires clause, if const expr. These are all C++20 features. Now I'm building this for C++20. SonarLint has spotted that. Says, well, if you're using C++20, there's better ways to do this now. They're going to be cleaner, less error prone, and faster build times. But if you're not convinced, it will also show you a rule description that we can click into. And you can see it classes this as a code smell. So it's not a bug so much, but something that you want to address for the cleanliness of your code. And quite a nice in-depth description of what the problem is, some examples of code that doesn't comply with this rule and examples that do. Here we've got the requires clause, we've got a concept here, and here as well. So there's even a link at the end to a standards paper going into even more depth if you want to dig into this even more. So quite a lot there to help you to work out why this might be an issue, what you might want to do about it. And if you've only just moved to C++20, it can be really handy modernizing your code by using some of these rules. But that's not the problem here. There's also one here down here, very similar, saying that this shared pointer, we should replace the redundant type with auto. Now, I'm not sure if you see that. It's actually gone off the top of my screen share. Let me, we can see it down here anyway. Replace the redundant type with auto. Nice thing about this one is I can actually do a quick fix and it will change it to auto for me. So in this case, typing auto instead wasn't that big a deal, but sometimes that can actually be quite a time saver and also help you to perform that change correctly. So there's one more issue that we haven't looked at. This is the actual issue. We see the stood forward of this template type here, but it's not the forwarding reference. Really, that should have been forward ref here, but it's actually the template for the overall struct. Very easy to miss this, very easy to get this wrong. And it's not always obvious, and it does compile, and it does run, but it gives you different behavior in this case. If I run that, you can see the result there is true. But again, there's a quick fix available. So we'll replace that with forward ref. Let's rebuild that again, run it again. Now it prints false. Easy to miss, but a very real bug we've just got in our code. And SonarLint found it nice and easily. So that was the first one I wanted to show you. There's another one. This was also from the ACCU quiz. This one, I think, at some point was probably taken from some boiled down parser code. So you can see we've got a token here, which just wraps a string, a stood string, takes it in the constructor, adds some comparison operator overloads. Again, C++20, so we've got the spaceship operator. And then we've got a load of tokens that you might see in C++ code. It's got this as a vector of strings, but we actually want a set of tokens. There's a couple of ways that we can do this and make it nice and easy to look up tokens in this set. The simplest way is just to copy, using the iterators, the vector of strings into the set, and it's going to invoke that copy constructor, conversion constructor from stood string, give you the tokens. Great. There's an alternative though. It's been around since C++14, maybe not quite so well known. If you give it stdless, which is a way to overload the how it does comparisons, with an empty template list, empty angle brackets there. This is known as the transparent comparator, if you haven't seen this before. And what this will do is it will give you templated comparison operators, so the types you're comparing don't have to match. So you could compare, a stood string to a string literal, for example, or in this case, a string to a token. And because it's doing that as a template, it doesn't have to convert one side or the other, because the types don't have to be the same. So this was added really for performance reasons, so that we can avoid a conversion when we're looking up something of a different type that we can compare with. So the question is, which of those two is more efficient if we do a find? A here on the non-heterogeneous type, the one without stdless, and B using the so-called heterogeneous container, the one that uses the transparent comparator operator, the type. Now you might think, based on what we've just said, that yes, of course it's B. That was added for performance reasons, and that was probably what a developer may have chosen this to do, to optimize the code. Unfortunately, they've seriously pessimized the code. And again, I actually meant to have that one running that time, but now we can see what SonarLint says. Provide heterogeneous comparisons between string and token, or make the container non-heterogeneous. So it says what we tried to do, but what we've missed is we've got a nice spaceship operator here. It's only comparing between tokens. And that means that it's going to have to convert that string to a token for every single comparison, rather than just once in the non-heterogeneous kind. So again, SonarLint has found that despite our best efforts to optimize the code, we didn't quite make it, but SonarLint has our backs. And it's a relatively obscure feature of the language as well to get right. So that was the second demo. There's one more I want to do in SonarLint before we move on. And I really like this one because it actually caught me out for real just recently. It's going to have to do a new share because it's in a different window. Hey. So I was recently doing a talk on coroutines, another C++20 feature. And this is part of the code base. And I was actually just going over it again for the last version I did, and I was optimizing this a bit. You can see this deserialize function. It's taking a vector of strings. And, as you would normally do, it's taking it by const ref. That's the idiomatic way to take containers or any large objects. And usually that would be fine. You can see that it's highlighted here. So SonarLint has found something. If we hover over that, it's going to tell us that we should pass this parameter by value. It may be used after the coroutine is suspended and may become dangling. Wait, this is a coroutine? Well, if you know anything about coroutines, you know that what makes it a coroutine is if you have any of the co__ keywords present, co_ await, co_ return, or co_ yield in this case. That was just off the bottom of the screen. It can be really hard to miss that. And if you're just looking at this code, you might think this is the right thing to do. But if I run this, it actually crashes. In fact, it crashes slightly differently every time because we're using undefined behavior. And again, SonarLint spotted that. This is a really hard to find, a really nasty bug that is very easy to introduce when you're first getting to grips with coroutines, or even if you know what you're doing, because it's so easy to miss. This is actually a coroutine. But the other nice thing here is the reason this could be dangling is because after this co_yield, the version of the vector on the stack above this may no longer be there because we may get resumed at a different time. But if this coroutine initially suspends, which it does, and we don't use IDs in this case after the co_yield, so if I just put a break in there, so not something you would normally do, but this demonstrates that after this point, IDs is no longer used. You can see the highlight goes away. It's smart enough to know that this is safe if what you pass in is only used in the initially not suspended part. So quite a nice in-depth knowledge of how coroutines work there that saves us. And again, to actually fix this, I can pass that by value instead. If I run that now, then it all works. Again, SonarLint has saved us. So that's great. That's SonarLint in your IDE. Obviously, there's lots more rules that can help us, not just with C++20, but our older code as well. But that's in the IDE. Now I have another demo to show you in another screen share. If I can find the right one again. I think I've got too many screen shares today. This one, right. Because we have another tool. This is SonarCloud. So as you can expect, it runs in the cloud. We host this one. If you want to host your own, we have SonarCube, which is very similar. There are some other differences as well. Now I've already set this up to analyze catch 2, which is, I think it was mentioned in the opening bio. The original author of this test framework. I've not actually worked on it actively for a few years, but still know it fairly well. And I thought, well, actually, when I first joined Sonar, I obviously ran SonarCloud against catch 2 to see what it would bring up. This is that original run. I've just recreated it. I haven't touched this in any way to try to make it special for this webinar. This is just as it came. You can see there's 5 bugs it's found, 813 code smells. Fortunately, no vulnerabilities or security hotspots. We can also measure coverage and even detect duplicated code just by running it against your CI. And the integration is pretty easy to get up and running with, even in C++. I'm going to skip the actual setup today. So let's have a look at some of the things it's found. Have a look in the bugs. So the first one, std move shouldn't be called on the forwarding reference. If I click through on that, you can see std move of result, and result is a forwarding reference. Probably not what was intended. So I think that's a real issue there. Now the next one, mutable context, it says could be null. Now you can see all these numbers here. This is another feature that you can actually have in SonarLint as well. I think it's viewed particularly well in the server tools. These are called secondary locations. So we have a look. We can actually see in a separate function, this is where it all starts. When we call get current context, then go to get current context, that calls get current mutable context. That comes up here, 3 and 4 on the same line. So that assumes that current context is null, because as far as it's concerned, it could be. And assuming the pointer is null, it's basically the same thing. Then it's going to take the true branch. Now, what it doesn't know, because how can it? Because it's a side effect. This create context, when it says it in the name, it actually creates that context on the heap. So after this line, current context does have a value. So I happen to know, because I know this code, that is not actually an issue after all. That's not to say it's not dodgy code. This is hard to reason about, and it could be error prone because somebody could change an unrelated piece of code and cause a bug. So it is really worth being shown these, even if sometimes you think, actually, that's okay. And in that case, you can say resolve as false positive or resolve as won't fix. So it won't just keep showing us that. So let's oh, put something in there. Let's close that as a false positive. This one is quite fun, actually. So this count here, we can see it's a uint 32, unsigned, and we're negating it. And we're doing all this bit shifting. This looks very suspicious, but we can see in the comment, it's safe, thanks to John Regger. If you know John Regger, you'll know that he knows his stuff. And there's even an attempt to disable warnings on this because everybody warns about this. But in this particular instance, again, it's safe. So I'm going to mark that as won't fix in this case. I won't put a comment. And the last two are sort of the opposite of the first one. Forward should only be called on a forwarding reference. So again, template parameter, not the template for this function, but we can look up a little bit for the whole class. Again, very easy mistake to make. And as we saw earlier, this is a real bug. So the last one is very similar. Stood forward called, which should have been stood move. Very easy to get those mixed up. SonarLint has found that for us. So most of those are real issues, and those that weren't, we definitely wanted to be notified of. I'm just going to have a very quick look in the code smells. A lot of these are just because the namespace doesn't match the regex we've got set up, so we could easily deal with that. But then we got some things like stood forward, never called on this forwarding reference argument. But that's probably something we want to look at, why that's going on. But I think the main thing here is there's 813 issues. Do we really want to sit here and go through all of these? Do we really want to be overwhelmed with this every time we deal with this code? This is one of the number one reasons that people give up on even compiler warnings, let alone static analysis tools, just being overwhelmed by the sheer number of issues in existing code bases. So what can we do about that? I'm going to go back to slides for a moment. Over here. And continue on. I'm actually running a bit short of time, so I'm going to rush through this a little bit. This is a photo of a ship. Happens to be the Vasa. I was in Stockholm earlier this year and went to the Vasa Museum. Bjarne Strastrup wrote a paper called Remember the Vasa a while ago. That's not why I'm showing this. I'm using it as a stand-in for another ship, a mythical ship called the Ship of Theseus. You may have heard of the Ship of Theseus, sort of a philosophical mental exercise. The idea is that the ship over time has more and more parts replaced until eventually every part of the ship has been replaced. Is it still the same ship as the original Ship of Theseus? Well, that's very similar to what we've been talking about, that our code changes over time. And there was a repo in GitHub by a guy called Eric Bernardson, who actually wrote a load of scripts to run against Git repos, see how they progress over time. One of the charts on there is the percentage of commits still present in code in a code base over time. And there's something a little bit familiar about this. If I actually go back to the previous slide, is this actually the Ship of Theseus, or is it the Git of Theseus, which is the name of the repo, as it turns out? So yeah, over time, more and more of the code is replaced. And if you can see the red line there, the average, you see that after a couple of years, about 65% of the code remains, 35% has been replaced. And after 5 years, it's the other way around. Only 35% of the original code remains. 65% has changed. That's even more than the generally accepted industry standard figures of 50% after 5 years. So with that in mind, if you only focus on the new or changed code in a code base and keep that clean, using tools like SonarLint or SonarCube or SonarCloud, then after a few years, you will have basically cleaned up all of the code without any additional effort. And not only that, it's not just 50% of the code or 65% of the code, but it's that part of the code that you look at the most often, that gets changed the most often, and that needs to change the most often. And this is our clean as you code philosophy that we've implemented particularly in SonarCube and SonarCloud. And I had actually wanted to show a demo of this, but I think I've underestimated the amount of time. So I'm going to skip over the demo and just say that we analyze pull requests and new commits, and by default only show you new issues in new code or changed code. So over time, you will eventually clean all of the code, but without any additional effort, as we said. Not only that, but it will show the analysis of pull requests directly in GitHub or other distributed version control systems. So I'm going to very quickly run through the last couple of slides because there's a few things I didn't talk about. I wasn't going to talk about much anyway, like quality gates that you can set up and configure, how the tools actually work together, something called connected mode, they can talk to each other. But I think we are going to have to rush to the end. I'm not sure if we have time for questions now. So I'll hand back to Anne to to see whether we can.
Thank you, Phil. Well done. So we do have a few questions from the audience, and I know we are at time. Those of you who have to go, we will give you all the questions and answers in the follow-up email. For those who have a couple minutes to stay, I think we'll do just a few questions from the audience and then let everyone get back to their day. So I want to start with your use of SonarLint. We had a question about if someone's using Clang Tidy or some of these other static analysis tools, is SonarLint also valuable?
Absolutely. So I was showing you C-Line earlier. C-Line bundles Clang Tidy with it, so it's automatically doing Clang Tidy analysis, but without SonarLint running, it wasn't showing any issues in any of the code that I showed. Now, sometimes there will be an overlap, so we do try to also replicate Clang Tidy rules in our analyzer. Sometimes Clang Tidy will have some rules that we don't have yet, so it's worth running both anyway. But yeah, we go a lot further. We'll often go deeper. There are some cases where Clang Tidy will actually tell you the wrong thing, and we correct that. So it's worth. I would say it's always worth having more than one analysis tool, so you can pick the best one if they fight.
Okay. And then in SonarLint, we had a question about your coding idiom. The question is there a reason why you weren't using namespace std, why you spelled that out every time?
I mean, me personally, I always like to use std explicitly. If you are going to do using namespace std, please only do it in CPP files, not header files. I've seen that done too often, but it is a matter of style. I've just got used to that over the years, and many people I know do the same.
Okay. So another question about the tool set. You talked about C++. Are any other languages covered by these tools?
Absolutely. Yeah, we have, I should forget now, maybe you can remind me how many languages we cover, but it's quite a few, including the main ones that you would think of. So, C#, Java, Python, JavaScript, of course, even Swift, but even some less well used languages these days, like COBOL, and a few that I hadn't heard of before I joined, like ABAP. So quite a few languages, but the main ones are definitely covered.
Okay. And then just before we let everyone go, do you want to say anything about the range of supported compilers?
No, but I will, because I don't know the absolute answer to this, but I do know that we support by default Clang, GCC, Visual C++. I know that we do have some support for some embedded compilers, but that's early days at the moment. So
Okay.
Abbas in the Q&A can probably answer more fully.
And what about Visual Studio? Is that supported?
It is, yes. Yeah, Visual Studio, VS Code, C-Line, even Eclipse.
Okay. All right. Thanks, everybody. I know we're over time. I appreciate you staying if you were able to do that. And if you weren't, I guess you're watching this in the recording. Thanks for coming, and we'll see you next time.
Thank you all.